going to talk about converting between polar and rectangular coordinates and polar and rectangular equations. Now, it really is sad to me that my students, you aren't in my classroom right now, because we would have a lot of fun drawing these graphs. These graphs are way fun to draw, and you can do them on the calculator. You can see the equations that are kind of down below them, where A and N are just numbers. If you have a graphing calculator and you want to play with them, you're welcome to do so. On your calculator, you would go to Mode, and you would change it to, here, let's see if I can even pull up my calculator. You would change it from function to polar, and then you can actually graph all these kind of fun graphs. And we talk about how we graph these. And so under mode, instead of function, we'd go to polar. And you want to be in radians as well. So if I go to y equals, notice it's not y equals anymore, it's r equals. But I could do like a 3 sine 5, and now I have theta instead. And then if I graph that, woohoo, there's some fun flowers. So you could do some fun things and actually get a little creative on some of your graphing calculators if you really wanted to, and play with the colors and stuff. So there's some fun things you can do if you want to play with that. But what we are going to do is we're actually just converting between different forms. That's going to be our easiest thing. These are the formulas you need to know. I cannot stress enough. These are the formulas. We have coordinates that go x comma y, and these are what we call rectangular coordinates. And then we have r comma theta, and those are polar coordinates. And likewise, we have our conversions here. If it's got x's and y's in it, it's rectangular. If it's r's and thetas, it is polar. And our theta will always be between negative 180 degrees and 180 degrees. You can use radians as well, but for ease of this homework assignment, we're going to use degrees. All right. Pause this video if you do not have these written down. For my trig students, if you have your note cards at home, pause this video, write this down. This is a note card that you should have. These are very important things that you need to hang on to because you'll be using them in the remainder of your assignments. All right. These are now, when it says change into polar form, these are in rectangular, and we need to change them to polar. Well, a couple of formulas on the other page that we had, if you recall, were r squared equals x squared plus y squared. In case you didn't see that, it was up here at the top. That is one of our coordinates that we need. And then we'll use one of those others in a second. We also have to kind of estimate where these are at, and that will help you determine what coordinate or which trig function you should use. So if I were to sketch a quick graph of these, 2 point something and then negative something. So I'm down here in quadrant 4. Here's what I will tell you. If you're in this quadrant, you can use any of the trig functions. My recommendation is using tan, but you can use any of them. Down here, you would use sine or tan. Those would be your two options. That would give you your exact answer that you need. Here, over here, use cosine. Use the cosine. And what I mean by these are these right here. So we're needing to find theta, so you'd have to set up a trig ratio and then solve for theta. What I'm talking about is these right here. All right. All right. If you're in this quadrant, I would use cosine again, but then you're going to make theta negative when you're done. Because what it'll do is I'll have to double think on that one. Because cosine over here will be negative. And so, but a negative cosine will pop you to here. And we actually want to go this way. So you would use cosine and then just make your theta negative. Anyway, like I said, here, sine, cosine, or tangent, any of those would work. All right, sorry, I kind of got interrupted there. Let's change part A here first. All right, we're going to change our x and y to r and theta. Oh, there we go. So right now, this is x and this is y. So let's find our r. So to find r, we have to use this r squared equals x squared plus y squared. And really, the negative is not that big a deal there because when I square it, it becomes positive. So r squared is going to be this 2.345. Come on, calculator. And I get 7.2467, really. And you're going to do the square root of that. So our r, and we're going to round to 3 decimals, will be 2.692. There's our r. Now, like I said, we're down here so we can use sine or tangent. I would recommend using tan at any time possible because otherwise you're going to be using a rounded number, which is fine as long as you leave it in the calculator, but tan is usually easier to use. So, like I said, when you're over here, use tangent if at all possible. That makes life a whole lot easier. So, if you recall, I think it was tan equals y over x. So tan theta equals negative 1.322 over 2.345. And then we'll do tan inverse of that to actually get that value. And we get theta to be negative 29.4 degrees. The way we write our answer is we write it as an ordered pair still. It goes r comma theta. We'll have r comma theta is how we write our final answer. So I'm going to write our answer down here under this, and I'm going to put it in blue so it stands out a little bit. So our r we got to be 2.692. And comma, we got negative 29.4 degrees. So there, we've converted that one to polar. Now let's convert this one to polar. Or actually, why don't you pause the video for a moment and why don't you guys try it? And then I'm going to just put the answer up there and you can see if you get it right. Okay, so this is the answer that I got for part B. Now, if you didn't get this, remember that to find our r, we did x squared plus y squared. You don't need the negatives on there when you square them, but if you do have them on there and you're using your calculator, make sure you put that in parentheses. Otherwise, it is going to cause you a problem. And the square would go outside the parentheses. All right, and then you'd square your final answer after you add them together. To find this, I used cosine. So I did cosine inverse. And then to use your cosine, if you recall, it is the x over r. So x here is negative 2.34, and then our r was our answer we found, which was 4.252. Now, like I said, I would leave this exact in the calculator, so I actually did cosine inverse of negative 2.34 divided by, and then I went up and grabbed that answer. What I mean by that, so let me show you really quick. I'm going to go ahead and hop out of, it's not going to matter on the home screen, but I'm still going to show you. So, like I said, if you're using the negatives on there, make sure you are using parentheses around this before you square it. And then it makes it a whole lot easier. Or you don't have to use parentheses and you don't have to use a negative because you know when you square it, it's going to become positive. All right, so that's that one. And then what I mean by grab our answer is I just come up here and I grab this. And then I push enter. So there's that one. And then I'm saying, okay, I want to do cosine inverse of that negative 2.34 divided by, and I'm going to push up and grab that answer again. So that's allowing me to use my calculator to the exact form. By the way, I'm in radians, and I could tell that because that angle was way too small. So if I do that and I just push, come back up and grab this again, Notice it's 123, which by the way is positive, and I had a negative here. That is because a negative negative puts me down here. So I still used cosine, but then I made it negative. So this little quadrant or graph will help you with these things. So make sure you have that written down somewhere as well. Going from, let's see, changing into rectangular, going from polar to rectangular, I find much, much easier. And that is because we have these two formulas right here. These two formulas make life a whole lot easier. Because we are already given r and theta. All we need is r and theta to find our x and our y. Likewise, on part A, to find y, we just do 2.4 times sine of 35.7. Find our x, we do 2.4 times cosine of 35.7. It's going to take care of everything for us. We don't even need to worry about it because we're just going to type those in the calculator and get our answers, and then our answers are written as ordered pairs. So if I have that, if I do the cosine one first, I get 1.949, comma, and then I'll use sine second because that's my y, 1.400, and that's rounded to 3 decimal spots. So there's that conversion. It is literally the easier of the two things. You just multiply and do that. So why don't you pause the video and try part B and then unpause it to see if you're right. Well, how'd you do? Did you get it right? I hope so. Once again, these conversions, very easy to use. All right, now what if I had to change equations? So I'm going to come back over here and I'm going to grab a few things. I'm going to grab that, that, and that. Those are the things we need to be able to do our conversions with. All right. So if I'm going to polar, the first thing I look for is, do I have an x squared plus y squared anywhere? Well, I do. I have an x squared plus y squared right here. Well, that's going to turn into r squared. So that all goes to this. Minus 2, and then, okay, well, what does x equal? X equals r cosine theta. So I'm going to have 2 times r cosine theta. And then 0 doesn't do anything, it just stays at 0. I look at these two things, I do have an r in common, so I could take an r out and end up with r minus 2 cosine theta equals 0. I could divide by the r, 0 divided by anything is 0. So really, my simplified form here could be this. Honestly, I would take any 3 of these answers. And you may be thinking to yourself, hey, none of those look like answers. Well, yeah, none of them really do look like answers, but they are your answers. So I'm perfectly okay with you leaving it like this, because then it shows that, yes, you got all the different conversions in there, and I can see exactly what you did. But don't overthink these. They really aren't that bad, but most people like to overthink these because this does not look like an answer, but it is an answer. Now we're going backwards. So how do I change these? Well, let's pull these back over here so I can look for them. All right, once again, on these, I'm looking for either an r squared or an r times sine theta and an r times cosine theta. I'm not looking for the 3 times that. I literally need an r there. Well, here's the problem. I have an r and I have a sine theta, but they're not doing anything. So I need there to be an r on this to be able to make it work. In order to do that, I'm going to take this side times r, which means I need to take this side times r. But we all know that 0 times anything is 0. Okay, on this side, let's distribute the r. So we'd end up with r squared plus 3r sine theta. Now things are looking kind of familiar. I have an r squared. Well, r squared in rectangular form is x squared plus y squared. Okay. I also have a 3 and then an r sine theta. Well, I know r sine theta is y. So I'm going to leave the 3 alone and just change this to y, which makes this a plus 3y. And yes, that is your answer. That is literally all you are doing with this. So don't overthink these. They don't look like answers when you're done. You're not solving for anything. You are just changing the forms. So good luck with that. I know you guys can do it.